Explain like I'm 5. If skin doesn't pass the scratch test with steel, how come steel still wears down after a lot of contact with skin? E.g. a door handle. Can't scratch is not the same as can't damage. Every time your skin contacts a piece of steel, it's leaving behind oils and moisture. The oils and moisture can chemically corrode the steel surface ever so slightly, forming iron oxide. While iron oxide is still harder than your skin, it's also weak, porous, and brittle. The next touch or cleaning can wear it off, exposing clean steel that can be corroded and eroded again. It might only be a few molecular layers at a time, but over hundreds of thousands of uses the wear adds up to a noticeable amount. Lesson I learned as a mechanic. Don't treat real stuff like physics theory. Your hands are dirty. The air, not pure skin. Sand on your hand, dirt, or other debris can really enhance how abrasive you are. For example, air is easily cut by steel. However, wind erodes steel, not because air is a hard solid but because it carries hard solid particles. Edit. Hey. Thank you all for the replies, fun facts, and thoughts. I'm really happy my post served this community well. Special thanks for the award. Luculent. Worth mentioning is that your hand is replacing lost cells continuously. If it didn't, you'd be out of hand's way before the door handle shows much wear. Imagine you had wet hands, stuck them in sand, then grabbed your door handle. This is a very exaggerated version of what's primarily happening in a lot of cases. The metal could also corrode, turn to rust. Even from the sweat on your palms, it's not much. But it doesn't take much, especially for just a surface layer. The scratch test only shows visible damage. However, at any interaction between any materials, there will be surface changes on both. A few atoms will get randomly displaced even on the harder material, simply due to the way the interaction energy is distributed. You will always get a few atoms knocked off due to outlier values for interactions. So you get a few atoms moved, and then again, over a large number of interactions. It starts to add up. Do not assume that the scratch test means there are no changes whatsoever to the harder material. There are always some changes. Given some ridiculous timeframe, geologic scale, you could probably polish a diamond with butter. Erosion affects all earth materials. Water cannot scratch rocks. However, with continuous movement it can wear down, peel off surface materials. Sharp rocks become smooth with friction. Similarly, your hand is squeezing and rubbing the metal on the doorknob, pulling tiny particles off. With time, the doorknob wears down. Also, note that there are different grades of steel. Some are higher quality and wear down less quickly. Skin wears out all the time. However, your skin can regenerate and heal. Wounds and scratches heal. Your body produces new skin which gradually sheds with wear and tear. The doorknob wears, but the wearing accumulates and thus become visible. There's basically a lot of difference between ideal cases which are taught in theory and what actually happens IRL. Skin isn't just pure skin. It's got debris, traces of other chemicals, because you touch your hands everywhere, and some microorganisms which together have the capacity to wear down steel. Lots of answers about moisture and oils and stuff which I'm sure is valid, but I would also like to present you with the horrifying thought about how much skin you would have left if it didn't regenerate. Greater than scratch test with steel. Can someone ELI5 this bit for me please? Because two things touching or rubbing will wear both things at least a tiny amount. If one material is much harder than another, it wears much slower than the softer material when they rub together, but it does still. Where, if you put a diamond in a tumbling machine full of soft rags or soft plastic beads and roll it around in there for long enough, the diamond will get measurably smaller. Most of the time though, it's that something harder is on the soft thing. There is sometimes sand or dirt on your hands. And even dust can have tiny bits of hard stuff in it. Similarly, when water wears away rocks on beaches, most of the wearing away is done by sand and other rocks moved by the water. Not the water itself. Your hands carry the harder stuff, and that tiny harder stuff is what does most of the wearing away. If the steel metal is not indestructible, it's made of atoms which can be worn away by anything. You could drill a hole through metal with a faucet dripping small water drops. Wear on a material is never negligible no matter the thing it is contacting. While a hard surface would wear a steel tool down very fast. Skin can do so as well, but just at a slower rate. Also, there is more than physical wear going on with skin. Skin is covered in oils and water which can wear the steel down chemically as well as physically. Because both surfaces get worn every time it makes contact. If only one surface got worn during every contact, then sandpaper would never need to be replaced. And neither would your brake rotors. Steel, especially the one used for decoration, is pretty soft 5 on Mohs scale. Most of the dirt is silica, which is 7 on Mohs scale. People have that dirt on their hands and it acts as a polishing paper, slowly wearing the steel down. If you ever seen a used steel watch with a sapphire glass, 9 on Mohs scale, the steel will be pretty scratched. But the glass won't. But if the watch was used by someone working with sandpapers a lot, the glass will also be scratched. Because some sandpapers are made from the same material, just less pretty looking one. Strength is a property of surface area. If you zoom in really close to the piece of steel, you see that it isn't actually perfect solid surface. It is rough, there are imperfections, little ridges and bumps, individual grains. If you consider their surface area, which is very small, the force they are subjected to exceed that of the material itself. So when a skin, with its ridges and bumps, makes contact, it can easily transfer enough force for an individual grain to come off. It is simple as that. It is an illusion that things we feel to be perfectly smooth, even though our touch is incredibly sensitive.